have questions, then you're going to speak into the microphone. Otherwise, you will not be heard. Only I will be heard, and that's not right. Huh. Take. So you just saw the movie, The Quantum Indians, and you learned about Satyendra Nath Bose, about C.V. Raman and Saha. And it was a marvelous movie. You learned how they changed the direction of physics back in the early 20th century. And so my question to you was, why don't we make a movie on the quantum Pakistanis? And I asked, who is a quantum Pakistani? And unfortunately, a lot of you couldn't answer that. But one person said, Abdul Kalam. And I said, that's the president of India. No, Abdus Salam. Abdus Salam, how come you guys haven't heard about him? He got the Nobel Prize in physics. If you were in Europe, you were at CERN, you would be hearing his name again and again. There's even a road named after him. It's called Abdus Salam Avenue in Switzerland. And here in this country, oh Shaheed Lieutenant Colonel फला, इधर शहीद कैप्टन फला. तो ये तो कुछ मेरा ख्याल है एक बीमारी है. Something is really sick about us. Why did you never, you're very smart kids, and you have not heard of Abdus Salam, most of you. It's because, unfortunately, religious prejudice in our country is far too deep for people to be able to think objectively. Abdus Salam was an Ahmadi, and so that's why he has been rejected by Pakistan. His grave has been desecrated. And even, that's so shameful. But let me tell you a little bit about, since you seem to know nothing about Abdus Salam, let me tell you what he did. There are 4 forces in nature. There's the gravity, which we talked about, black holes and all that, or the earth that simply brings things down. There's the repulsion between protons and protons, or electrons and electrons, and that's the electromagnetic force. And then there's something that breaks up the neutron, and that something is called the weak force. And there's a 4th force, which is called the strong force, and that is really the nuclear force, because when you have, let's say, within the nucleus, protons and protons, then ask the question, why doesn't that nucleus break up? And that's the strong force. So now what Abdus Salam did is he showed the essential similarity between the weak force and the electromagnetic force. It's built entirely upon quantum mechanics. In fact, a higher level of quantum mechanics, which is called quantum field theory. This was a revolution in its time. He discovered this in 1967. He made predictions that were found to be true in 1979. And in 1979, he got the Nobel Prize. He came to Pakistan. He came to my university, Quaid-e-Azam University, and he was not allowed in the university. जो जमात इस्लामी के स्टूडेंट्स थे, उन्होंने कहा कि हम इसकी टांगें तोड़ देंगे. Shame on them. ये दीवानगी, ये पागलपन सिर्फ उस मुल्क में हो सकता है जहां लोगों की अक्ल खत्म हो गई हो. Sorry about that, but it's really tragic that we do not celebrate the one single quantum Pakistani when we have today seen quantum Indians. And by the way, not all those quantum Indians were Brahmins. उधर भी तो फर्क है ना between Brahmin and Dalit, वैश्य और शूद्र, इन सब में फर्क है. लेकिन वो थोड़े से पागल हो गए आजकल, बहुत पागल हो गए मोदी के होते हुए. लेकिन फिर भी उन्होंने अपने साइंटिस्ट को तो नहीं भुलाया. अगर हम क्या पूरी दुनिया आइंस्टाइन को सेलिब्रेट कर सकती है जो कि यहूदी था, तो क्या हम उसको नहीं मानते? ना मानो. Disbelieve E equals MC squared, and then you are no better than people living in the Stone Age. तो जहां मजहब का कीड़ा खा जाए ना दिमाग को, तो उधर ये हालत हो जाती है. Okay, guys, now let's get on to the real topic, and I need to set up my computer. तो यार वो तार लगा दो उधर. We're going to talk about the Big Bang, the early universe. How do we know that the Big Bang actually happened, and what was it? तो उससे we'll be talking about that, so you can reserve your questions for that. लेकिन अभी इससे पहले कि ये computer set हो, let's have some further discussion on it. CMBR, that's a very important result. Yeah, but there are two others. Yeah. Yeah. Redshift is a way of finding out about the expanding universe, but there's also another, and we'll talk about that as well. Any other quick questions? यार ये सवाल इनको he'll have to repeat it because it's a good question. उधर ये ऑन नहीं है. हाँ,
I think on it. Okay, so my question was that you were talking about that this sort of Islamic culture in Pakistan, especially in the subcontinent, is very opposed to scientists. Don't you think this is not from the actual Islamic thinking, but a sort of bigoted version, sort of extremism of Islam, which is not the actual the teachings, and how our golden age of Islamic scientists have shown that is not the actual representation what the subcontinent teaches?
It's a great question. I'm afraid I can't give you a straight answer. The reason is that I don't know what ideal Islam is, because the ideal Islam is different for him, her. Everybody has a different interpretation of Islam. And so I cannot say whether the prejudice against Abdus Salam is truly Islamic, or that it comes from so-called extremists. I would say that in Pakistan, there are a lot of people who don't consider themselves extremists, do not think of themselves as fanatics, but they're fully supportive of banning Ahmadis and of not having Abdus Salam as a national hero. So this is, you've asked me too difficult a question, because now I'm going to challenge you on this. What is the true Islam? Who speaks for Islam? Is it Mufti Falah or Mufti Falah? Or is it the Ayatollahs of Iran who speak for Islam? Or is it you who speaks for Islam?
I think the speaker for Islam was the Prophet Muhammad, and he spoke clearly. And I think even like let's take the example of all the sects, Shiism, Sunniism. I don't think any of them would actually declare that someone, let's say we consider Ahmadis as non-Muslims, so we wouldn't oppose him in making his scientific discovery. So I don't think that is a part of Islam. I think that is a part of subcontinent culture most.
In Bangladesh, they invited Abdus Salam immediately after his Nobel Prize. In India, they did the same. In Pakistan, they invited him but would not allow him to travel around. And I said, Salam came to my university and the students threatened they would break his legs. Hum uski taange tod denge. He could not go to any university in Pakistan. And yet he could go to Morocco and Algeria. He could not go to Saudi Arabia because Saudi Arabia at that time had a different Islam from the Islam it has today. So, my friend, I don't know what is the true Islam. Is it the Saudi Arabian Islam of 50 years ago? Or is it the Islam of Saudi Arabia today under Mohammed bin Salman? It changes from time to time. But look, let's not spend too much time because I have to tell you how the universe started and how life started. One quick intervention. Acha, jaldi se.
I somewhere do agree with the point you've made. And the other day we had a lecture about law, and we discussed the blasphemy law there. And like people like Mashal Khan, if he wasn't killed in the way he was, maybe he would have done something amazing for Pakistan. So not even like a particular sect, but this ideology of going against people who are doing something unconventional, I think, is somewhere in this country. So how do you think would we move forward if we just have this integrated in ourselves?
To my mind, so as I'm setting this up, to my mind, it's by separating religion from politics and religion from science. The two together cannot travel. Okay, so now let me. ये क्या हुआ? आ गया? ओह, और इसमें मुझे स्लाइड चेंजर भी लगाना होगा. Right. So, how do we effect that change? By creating minds that are open. How do you create an open mind? You look around the world and you see how others behave with their own kind and with those who are slightly different. And so I don't have a recipe, I don't have an exact answer, but unless we become open-minded, there's no way of moving forward in the world of science or in other ways either.
So are we moving forward, or you don't think so?
But that's for your generation to
Okay. Thank you.
आगे इधर.
I completely agree with your point that religion somehow limits our thinking. That we can celebrate a non-Muslim Einstein's discoveries, but we cannot celebrate discoveries of a Muslim who interprets Islam in a different way.
Yeah. After all of science, all of modern science has been created by non-Muslims. There is not a single thing that we see today, whether it's electricity or antibiotics or cars or computers or whatever, that Muslims have made, because Muslims have done no science for the last 900 years. Okay, good. So we are here finally. I'm going to ask some really big questions. What is the world made of? What holds up the earth? You know, there was this idea that the earth was held on the horns of a bull. When the bull shakes its head, earthquakes happen. Where did we come from? Why are we here? Could there be life elsewhere in the universe? All these big questions. So there's been thinking on this ever since humans have been around, and the ancient Greek philosophers, very wise men, Plato, Aristotle, Democritus, Socrates, Pythagoras, they had their ideas, which is not to say that they were right ideas, but they did. And so what holds up and what holds up the earth? It makes sense. It's got to be a big animal, right? What's the biggest animal that we know, mammal that we know? Well, the biggest is the whale, but on earth it's the elephant. But the elephant has to stand on something. A tortoise. But what does the tortoise stand on? Any idea? Yeah? Another turtle, brilliant. So it's turtles all the way down. But there must be a last turtle, right? What does he stand on? No, the earth is up there. But then, you know, things will be falling in all kinds of peculiar ways. No, he stands on a super turtle. Okay, we're not serious at this point. What do religious people who are Jews or Christians or Muslims believe? That God made the world. Some would like to say kun fayakun. Some would like to say 7 days. And the seventh day is why we have a holiday. It's called Sunday. यार तुम लोगों को पता ही नहीं ये बात. God made the world in 7 days. On the seventh day, He rested. तो थक जाता ना बंदा आखिर. So that's why you have a holiday on Sundays, but the Jews, they have it on Saturdays. It's called the Sabbath. चलो हर एक का अपना ख्याल है. I'm not saying any one of them are wrong, लेकिन ऐसे ही होता. अब हिंदुओं की सोच बिल्कुल और है. ये कि ब्रह्मा ने बनाया, he is the real creator, but then Shiva comes along, and he destroys the world because he says it's gone all wrong. So then it has to be rescued by Vishnu, who's a nice, peaceful character, and then he, builds up the world again. Again, I'm not saying this is wrong. It all depends on whether you were born here, there, or there. They're all right. सब ठीक है. So I'm only going to talk about the scientific view. And here we इस प्रोजेक्टर को थोड़ा सा ठीक कर लो, थोड़ा, ताकि इधर लाइट. हाँ, अब क्या हुआ, क्यों गायब हो गया? Okay, the scientific view. We're going to be talking about that. The scientific view does not depend upon where you were born or what you believe. It rests only on evidence. Evidence is that which we can access with our senses. What we can see, touch, feel, hear, and hear or see not just with our ears and eyes, but with our equipment. So the Hubble telescope is able to see far, far into space. And before we proceed, I must define the universe as not just the matter in it, not just the stars and the planets and the moons and all that, but also the space that is there in the universe, because this space wasn't always there. That space has increased over time and is still increasing, and that is what we call the beginning of the universe, when space and time were actually created. In terms of the matter that exists within the universe, well, there's a big scale over there from the atom. I'm looking at small things. So the atom is 10 to the minus 8 centimeters, or 10 to the minus 10 meters. And then there's the nucleus, which is 10 to the 4 to 10 to the 5 times smaller. And then within that nucleus, there are neutrons and protons. And within the protons and neutrons, there are quarks, which, so far as we know, are elementary particles. I always say, so far as we know, because science doesn't claim to know everything. In fact, it is very happy, very satisfied with saying that we'll discover things with time. But that doesn't mean that we negate what we've learned from science earlier. देखो, एक ही दफा हमें ये पता चलेगा कि सूरज के गिर्द प्लैनेट्स घूमते हैं. अब बाद में फिर हम ये जानेंगे कि वो प्लैनेट्स कैसे बने, कि उनकी अपनी साख्त क्या है. वो बातें बाद की है ना. We keep refining our knowledge, and so science is very, very proud of it not being the final word. Just a little bit earlier, I told you about the fundamental forces of nature, which are 4 in all. There's the weakest of them, which is gravitation. I say weak, बहुत कमजोर है, but that's a technical matter. भूल जाओ अगर ये बात समझ में ना आए. Then there's the opposite. This is the strong interaction, which is the strongest of them all. This is intermediate in terms of strength, and this is the weakest of them all, the weak interaction. And as I try to explain, the unification of the strong and the weak interaction is what Salam got the Nobel Prize for. Mike? Otherwise, I will be accused of answering a question that was never asked.
So I want to ask, is the weak interaction weaker than the gravitational force? Because I feel like I've always heard the gravitational force is the weakest of them all.
Yeah, the weak interaction is billions of times weaker.
Then the
Sorry, मैंने उल्टा कह दिया.
Okay.
The gravitational force is billions of times weaker than the weak force.
And sir, I wanted to clarify the reason why these other three forces don't dominate the universe, because especially for electromagnetism, they've got positive and negative, so they kind of cancel out, while gravity works regardless of any charges or cancellations.
Yeah, that's an interesting point. Gravity doesn't have charges. And so there's no negative gravity that is possible. But in terms of what dominates the universe, gravity. Because there's just so much matter in the universe that gravity is the most pervasive of them all. It's there everywhere. देखो ना, अगर gravity ना होती तो हम ऊपर उड़ रहे होते इस वक्त. Okay, so now all matter as we know it, and this through the last 100 years of progress in particle physics, that we know that there are 18 elementary particles. There are quarks. These quarks make up the neutron and the proton. There are leptons like the electron. अब देखो ये जो ब्लू एरिया में इलेक्ट्रॉनिक्स की दुकानें हैं ना, ये वो वाला इलेक्ट्रॉन है. मगर आपको म्यूऑन की दुकान कहीं नहीं मिलेगी. म्यूऑनिक्स जैसी कोई चीज नहीं है. Any idea why? Because muons actually decay themselves. Electron doesn't decay. Acha. Then there is the one and only Higgs boson. Now, you know, you guys, if you had heard of Salam, when that quantum Indians thing came up, immediately you would have said, Higgs boson. But sir, the Higgs boson was discovered because Salam predicted that it exists. So, they don't call it the Salam boson, and quite correctly so, because Higgs had thought of the idea of spontaneous symmetry breaking, which I'm not going to get into, but that is what inspired Salam to think about a way of understanding unification. And Salam and Weinberg, they both got the Nobel Prize for this. They predicted the existence of these heavy photons. A photon has got zero mass, but these, the W plus, W minus, and Z0, they're about 80 times heavier than the proton, and the proton is 2,000 times heavier than the electron. So you can see why it was so difficult to discover them. But once they got discovered, well, then that's when they got the Nobel Prize. I've spent my lifetime working with quarks, but I won't. There are too many important things to discuss, so I'm going to not go into this. You never see quarks the way you see electrons because they're always making pairs with each other, and so they're bound into things called hadrons. And the fact is that if you were to break down your weight, you would be about 2,000 parts made of hadrons and by weight, and 1 part of leptons. And as I say, we can't ever forget space-time. Einstein would not let us forget that. He discovered that where you have mass, and a lot of mass, there space-time curves to accommodate that mass. So now the question, where did all this damn stuff come from? And it's the Big Bang. And two arguments I've already heard from you. Let's go over that again. So this is Hubble, Edwin Hubble, looking at the sky, looking at distant galaxies. He sees them all running away from us. And it's a remarkable discovery. He uses the Doppler effect, which is that if something is running away from us, its frequency goes down. The frequency of the light emitted from there goes down. This is the same effect, that the motorway police uses to detect the speed of your car. Correspondingly, if it's moving towards you, then you get blue shifted. And this is what Hubble discovered way back in 1918 or whatever, that the further away a galaxy is from you, the faster it is, the faster it's moving. That's called Hubble expansion of the universe. And there's a constant known as the Hubble constant, which is the slope of this line over here. So this is the speed in this direction. This is the distance of a galaxy from the center of the Earth, or from the Earth, it doesn't matter. And you see that the further away a galaxy is, the faster it is moving. Imagine that you were to make a video of this and run the video backward, then you would see everything coalescing into one single point. That's where the Big Bang happened. And the time needed to run the video backward, that's the age of the universe, currently estimated at about 13 billion years, 13.7 billion years. Yeah.
So the distance and speed are directly proportional.
Yes.
So does this only apply to galaxies or planets, or does it apply to everything in nature?
Only to distant galaxies. Only to very distant galaxies. It doesn't apply to it doesn't apply to things that are like a ruler will not expand by itself. Only things that are related to the expansion of the underlying space-time, it applies to that.
Sir, I would like to make a interesting comparison, and I want to know how you think about this. You were talking about elephants actually holding the earth, right? So I feel like in the times of old, that was the scientific way. People saw, okay, elephant big, so earth suspended via elephant. And I think right now we are the same. We have our own much developed scientific method, and we've discovered, okay, from the background radiation, we've discovered the Big Bang. So is it
आया ही नहीं हूँ background radiation तक.
Okay. I'm sorry, but I'm just saying that we, from our scientific method, we've also found, okay, we have this, we have another elephant, and we call it the Big Bang. So don't you think the Big Bang and the elephant turtle suspending the earth are as absurd?
Well, yes, it's absurd that the universe started from a single point. I mean, it sounds like nonsense. However, let's look at the arguments. One argument I said was that Hubble said, this universe is expanding. The distant galaxies, the speed he can find, the distance he can find, he finds Hubble law. And then the argument I gave you that take a video of it, run it backwards. So it's not so absurd, but it's not enough. We need to make a prediction. Next. So actually, you're right. It's very absurd. Because why should it be expanding when looked at from the Earth? What if I go to another part of the universe? Then it should be, should not be. How is it that every point in the universe can be the center of the universe? भाई कराची हो या मक्का हो या लास वेगस हो जहां जुआ सट्टा होता, वो भी center of the universe है. The other section of the universe, that is also the center. How can it be? Nobody could have had an answer except that Einstein had discovered the theory of general relativity. Okay. So in the Big Bang, एक मिनट इधर उधर रख लो. You have a question. Let the mic get to you.
Yeah, so sir, I wanted to ask that, first of all, what is the shape of the universe and how it's expanding? Is it expanding in a sphere shape?
Absolutely.
Okay.
Absolutely. Very important. This is called the isotropy of the universe. So you look in this portion of the sky or that portion, and when the earth turns around, you look at the portion over there. Everywhere you find a spherical expansion. All right, so this is what happened at the very beginning. There was not any matter. There was no atoms. There were no molecules, nothing. There were just protons and neutrons at one point. From those protons and neutrons, we can, using nuclear physics, predict the rate at which helium would form and all the heavier elements would form. And so this was a prediction made at the end of the Second World War that in the universe there would be 75% hydrogen, 25% helium, 24.9% helium. All the figures have points in them, decimal points. And then lithium, beryllium, boron, carbon, etc. You go out with your telescope and you find exactly that within experimental errors. So this is not the elephant holding up the earth. There's a predictive element over there. You talked about the microwave temperature fluctuations. You know, to spend time on this would then take us, we have only a few minutes, so I have to get through this fast. So we will skip that. All of these things you can see now with your super telescopes like this Hubble telescope, which actually, this is not a computer-generated creation. This is not AI nonsense. This is actually an exploding star. And this supernova creates all the heavier elements because you have so many neutrons that you can actually predict the amounts of various elements. So all the way from beryllium up till uranium and even beyond. And that's what a supernova experiment, that's what a supernova explosion does. And as Carl Sagan used to say, you and I, we are made of stardust. Because that stardust eventually coalesced. It led to the formation of planetary systems across the universe, including here on Earth, in the solar system. We also know how the Earth formed. It was extremely hot, it was molten, it cooled, layers formed, and today we have the Earth as it is. We also know why earthquakes take place, because when one solidified layer slips on another, then there's one part goes down, the other part goes up. That's what's called subduction in geology. And that's how it happens on all planets. And so if you say that this is because earthquakes happen because of your evil deeds, you'll have to explain how earthquakes happen on the moon. हमारे मौलवी साहिबान इस पे बड़े कंफ्यूज हैं कि चांद पर जलजले आते हैं कि नहीं. मैंने पूछा था एक टेलीविजन प्रोग्राम में, बहुत उड़ गए इस बात पे. अगर यहाँ ज़मीन पर हमारी ख़ताओं की वजह से ज़लज़ले आते हैं तो चांद पर क्यों आते हैं? मगर लेट्स मूव ऑन. More important things to discuss here. Life. How did that originate? And I have to do this in 10 minutes. In 10 minutes? 13 minutes. Good. I wish I knew what was life. Do you? What's a good life, by the way? No, I asked this rhetorically. There are too many people here. So just, what is life? How does inanimate matter, atoms, molecules, how do they turn into things that move, things that eat, things that excrete, things that reproduce? That's what life is about. And if there's life on Earth, could there be life in the rest of the universe? Questions. And what's going to happen to us? I don't have good news on that. So the old stories, the best one, okay, so the ancient Egyptians, they thought that life comes from eels and toads and fish and slippery things because they procreate so fast. And that it all comes from the river Nile, which is why they worship the river Nile as their god. The English had an even better explanation. Life comes from the dirty underwear of kings. I know, pretty gross, but yeah, and of course, every religion has some explanation of how life started. But for us, the scientific explanations, and we're not completely sure about this. Did life originate on Earth? Or did it originate in some other part of the universe where it could very well be that conditions were similar to those on Earth itself? And of course, I haven't answered the first question, what is life? It's something that regenerates itself. So living things will move, they'll eat, they'll crawl around, or they'll walk, or whatever. And how did this life actually start on Earth? When the stuff that came out from the supernova was just atoms and molecules. And the early Earth, so this is an artist's creation. This is not true because nobody was around in the early days of the Earth, but there were volcanoes spewing out all this sulfur dioxide, putrid stuff, and the Earth stank. There was methane, and you know what methane smells like? Poop. Horrible situation then. So how did life emerge in this horrible situation? Well, for life, you need energy, and there was plenty of energy in the form of lots of lightning, and there was water. That water was brought by meteorites from outside. Some of it was already present on Earth. And that's actually a great question. Where did the water on Earth come from? You can investigate that, look it up on Google, whatever. But there are two theories: that it was already there. Second, that it was brought in by meteorites. So then the question is, you have these simple atoms. You have hydrogen and helium and carbon, nitrogen, oxygen. How do you get something as complex as life to come from there? And life, of course, comes from proteins. So where did the proteins come from? This is a brilliant experiment called the Miller-Urey experiment. And you can see there's here water which is heated up, rises up, becomes water vapor. Here, just like in your car or your motorcycle, you have energy given through sparking, and that's then giving energy for making bigger molecules. Then you go out, you go and send this collected stuff to a chemistry lab, and there, amazingly, what was found was amino acids. Amino acids you've probably heard of. There are 20 of them. They are the building blocks of proteins. From the proteins, you have the simple, you have more complex molecules, ultimately ending in a predecessor of the